All right. Happy Tuesday. Today we are going to be adding fractions with related units, and we will be looking at tape diagrams and number lines as we do that. Okay, so the most important thing to remember here is everything we've learned over the past couple of weeks about really looking for common factors and making it easy to solve those addition and subtraction problems. So the first thing we're going to talk about is adding, like, if I were to say, what's one banana plus one orange? Well, we can't really add those right now, right? Because they are not like units. They're different. We can't say two banana oranges, right? We have one banana and one orange. Bananas and oranges do have something in common, though. What do they have in common? And hopefully you're saying, well, they're both fruit. Okay, so we could change their label and say, well, we now have two pieces of fruit. And it's important to keep this in mind when we start using numbers, because numbers are going to work just the same way. When our denominators don't match, we're going to be looking for something that they have in common to make it easier for us. Okay, so let's go ahead and kind of get started. Let's look at 1/3 plus 1/6. Can we add these right now? Hopefully you're saying, no, we can't, because there's not like units, right? So what can we do to rename one of the units? Well, first of all, let's think about, can we decompose thirds to make, or is it going to be easier for us to decompose sixths, okay? And hopefully you're saying, well, Miss Johnson, let's go ahead and take those thirds and make them sixths. So what we're going to do is look at this using a tape diagram and multiplication. Okay, so I have 1/3 plus 1/6. So let's go ahead and draw 1/3. So when I have a tape diagram, 1/3 is going to have 3 pieces with one shaded in, right? And then in order to make it sixths, I'm just going to draw a dotted line and decompose right down the middle. So now I have 1/3, and I'm trying to figure out how many sixths does that equal. So I would have to multiply by 2, right? Because I'm dividing each piece in half. So now I have 2 pieces in each. 1 times 2 gives me 2, and I know that 3 times 2 is 6. So 1/3 now equals 2/6. So now I can take that 2/6 plus the 1/6, and they have common units now. And that's going to give me 3/6, because if I add one more sixth, okay, it's going to give me a total of 1, 2, 3/6. Now, I would challenge you here. Remember, I've been challenging you. Is 3/6 in its simplest form? And hopefully you can look at this area or this tape diagram, and you can see that 3/6 is actually 1/2, okay? 1/2 has now been shaded in. Now, another way is you could do division, right? And you could say, well, 3 divided by 3 equals 1, and 6 divided by 3 equals 2. So 1/2 in its simplest form. Again, I would take 3/6 doing the addition, but I would give you some bonus credit here if you recognize that 3/6 is actually equal to 1/2. So hopefully you're seeing how finding common units helps you to add and subtract fractions. We will be able to show this on a tape diagram like we just did, also a number line, or an area model by the end of this lesson. So let's take a look at another one. This time, go ahead and get myself a fresh page here. We're going to add 1/2 plus 1/8. And can we add these right now? We can't, right? Because they don't have like units. So let's use a tape diagram to rename one of our fractions. So I'm adding 1/2 and 1/8. Which one are we going to rename? Well, we're likely going to decompose that half and make it eighths, right? Because we can't really decompose eighths to make them half. So let's take a look. We have 1/2 plus 1/8. 1/2 plus 1/8. So if I draw a tape diagram representing 1/2, my tape diagram's just got two pieces with one shaded in, right? And that equals 1/2. Now, if I wanted to make it eighths, how many pieces would I have to decompose this into? Well, I'd have to have 4 pieces in each, right? So now I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. So now my 1/2 equals eighths. And I know that because I divided it or decomposed it into 4 pieces in each little box, if I multiply the top and the bottom, or the numerator and the denominator, by 4, I'm going to get that 1/2 equals 4/8. So now I can take 4/8 plus 1/8, and I can add these because they have a common denominator. So I'm just going to add my numerators, and I have 5/8. And to show 5/8, I would have to shade in another piece, right? I'm adding an 8. So here's the half, or the 4/8 plus the 1/8. Okay? So take a moment, think about this, and hopefully this is like a light bulb for you. Now, is 5/8 as small as we can get it? It is, right? We can't really divide 5 and 8 by anything to make that smaller. So it is in its simplest form. Okay, try this one on your own. I want you to try this one on your own. So you might want to pause the video here and just try this one on your own. And let's see what you come up with. Okay, so 2/3 plus 3/12. Let's take a look at this one on our Jamboard. So I have 2/3 plus 3/12. I'm going to start by drawing a tape diagram. And I know for thirds, it has to have 3 total pieces with 2 shaded in. Now, if I want to take my thirds and make them 12ths, I need to go ahead. I'm going to change colors just so it's easy for you to see. I would have to have 4 pieces in here, right? Now, if I count my total pieces, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total pieces. So now I know that my thirds equal 12ths. And how many 12ths? Well, I could count them, right? Or I know that to get 12ths, I have to do 3 times 4, and that means I also have to multiply my numerator by 4, so 8/12ths. So you could count them: 1, 2, 3, 4, 5, 6, 7, 8/12ths. Now I can add 8/12ths plus 3/12ths, and I get 11/12ths, right? If I were to add in 3 more 12ths, I'm 1 away from my whole. I have 11/12ths. So again, hopefully you're having some light bulbs going off in your head and you're saying, well, renaming these fractions common units, not so hard. So let's go ahead and take a look at doing this with a number line, okay? So we're going to take 1/6 plus 3/12 and look at it on a number line. So the first thing we're going to do is 1/6 plus 3/12. I'm going to take my number line, and I want you to just draw your endpoints or your benchmarks and label them 0 and 1, okay? And then your halfway point, 1/2. So let's start by labeling 6. So we have 0/6, and 1 whole would be 6/6. Halfway would be 3/6, right? So then, whoopsie, sorry, let's see. And I have 1, 2, 4, and 5. Okay, so 1/6, 2/6, 4/6, 5/6. Now, how many pieces would I have to partition this number line into to make it 12ths? Okay, so if I rename my benchmarks, now I have 0/12ths and I have 12/12ths. Halfway between 0 and 12, my halfway point is 6/12ths. I need to partition each piece in half to get to 12ths, okay? So now I have 1/12 and I have 2/12, then 3 and 4, 5, there's 6 already, 7, 8, 9, 10, and 11/12, okay? So now I know that my 1/6 is actually equivalent to 2/12. So now I can add 2/12 plus 3/12 and get 5/12. If I start at my 2/12 and I add 3 more, 1, 2, 3, I land on my 5/12. Okay, now also looking at 1/6, I could know that it's equivalent to 2/12 because if I multiply my numerator and my denominator by 2, I get 2/12. And remember, I've partitioned my number line into 2 pieces where there was just 1 before, so I can multiply by 2 there. Okay, so that's how you could show it on a number line. And you can see all these other equivalent fractions on here. 2/6 is going to be equal to 4/12. Okay, 3/6 and 6/12. So that's another interesting way that you can just look at the number line and see a bunch of equivalent fractions. So we've seen how to add units with with a tape diagram, and now we've done it on a number line. So now I want you to try one more with a number line on your own. So pause here and go ahead and do 3/4 plus 5/8, and then we'll come back together. And hopefully, so we've got 3/4 plus 5/8. Can't add these. They don't have like units. So let's go ahead and take a look at our number line. We've got 0 and 1 and half, and I'm going to just start with fourths, right? So hopefully you labeled 0/4, 4/4, and we know halfway to 4 would be 2/4. So then we just have 1/4 here and 3/4 here. Now, if I wanted to partition to make eighths, I know I would have to divide each one of these little guys in 2. So now I have 8/8 and I have 0/8. Halfway to 8 is 4/8. Now I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. So now I have eighths. Looking at my 3/4, it looks like 3/4 is equivalent to 6/8. So if I take 6/8 plus 5/8, can I add these now? They have like units. I'm going to get 11/8. Okay. Now, I would have to increase the size of my number line if I wanted to show the addition on my number line, right? I would have to make it larger because 8/8 is here and I still have to jump 5 more, okay? But before we do that, let's reconstruct our number line. But before we do that, how could I rename 11/8? Okay, so let's think about that for a second. We've got 11/8. We know that it's bigger than the whole, so remember this is where you take your number bond. I have 8/8. How many more to get to 11? Well, 8, 9, 10, 11. 3 more 8s. So I know my answer is 1 and 3/8. Okay. Now, if I were wanting to take this number line and represent the jumping where you're adding on, I would simply need to make my number line larger, right? And I wouldn't have to go all the way to 2 because I know 1 and 4/8 is 1.5. So I could go to 1 and 1/2. Okay. 1 here, 0 here. 1 we know is 8/8. 1.5 we know is 12/8. Okay. And we know this is 0/8. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these will be bigger. Whoopsie, 8. And this isn't exactly that long. It should be more like probably this long. 8, 9, 10, 11, 12/8. Okay. 1.5. So I start at, let's see, we're doing 6/8 plus 5/8. Where would I start? Well, here's 7, here's 6. I would start at 6/8 and add 5. 1, 2, 3, 4, 5. And I would land at 11/8. Okay, so keep that in mind when you're doing on a number line. I like to probably solve first and then show my work on my number line, so that way I'm not having to draw more than one number line or erase and do a whole bunch of things. But the most important thing I want you to catch here is this part where we had to make the mixed number, okay? Not a new skill, something we've been doing. But I want you guys to get in the habit of making your mixed numbers and also making your answer, making sure it's in the smallest unit form. All right, so let's try one more. Let's do 2/5 and 3/10. What unit is it going to be easier to decompose, and how can we do this without a model? So let's try it without a model. So we have 2/5 and 3/10. Okay. 2/5 plus 3/10. Well, we know that our units are not alike. They're like apples and oranges, right? Or bananas and oranges. So we have to get them to be the same. When I look at 2/5, I see that it can be tenths. Okay? It can be tenths. What do I have to do to get to tenths? Well, I know 5 times 2 is 10. And I know anything I do to the denominator, I have to also do to the numerator. So 2/5 is actually going to equal 4/10. Now I can add 4/10 plus 3/10, and I get 7/10. I look at this, it's in its simplest form. That's the answer. I didn't have to draw a model, but I could if I wanted to. I really feel like this is something we've kind of been doing it in class already. But this has just given us a little more practice finding those common units. So hopefully you thought today's lesson was pretty easy. Let's go ahead, take a look at your problem set. So you'll be going for Tuesday, which will be have an orange dot beside it. The problem set instructions say, please complete the problem set after the check-in and Nearpod lesson. You will do all the problems except for letters C and D on numbers 1 and 2. Drawing a model or number line is optional, so you don't have to draw a model, okay? Even if the instructions tell you you need to, it's going to be optional. So number 1, use a tape diagram to represent and decompose to make like units. So again, you don't have to necessarily do the tape diagram. I think it's good practice, but you need to go ahead and find like units and then add. add, okay? Number 2, you are going to do a number line. So again, optional, I would like to see it. And then number 3 wants you to solve without drawing a model. So this is where you won't draw a model. So I don't really feel like there's anything tricky about that at all. Once you finish the problem set, you'll go straight into the exit ticket, okay? And the exit ticket for lesson 20, let's take a look. Draw a number line to model the addition, solve, and then write a complex number sentence. So you'll want to make sure that they have like units so you can add and do it on a number line. So I do want to see a number line here. And then for number 2, you don't have to have a model, but you have to show me the multiplication you use to get like units, okay? So pretty easy peasy. If you have questions, feel free to reach out. But I feel like you guys are going to just really knock it out of the park. So have a great Tuesday, and I will see you all tomorrow.